better tanks, new models of tanks are the order of the day. So here at one of the Army's proving grounds, the latest product of tank engineering, the light tank M-24, is being put through its paces. There's no kidding about these tests. They're called shakedown tests. That's exactly what they are. When the tests are over, the tank has shown pretty thoroughly what it can take and what it can do. So here's the straight dope right from the proving ground on the Army's new M-24 light tank. When you compare it with its forerunner, the light tank M5, you'll catch some radical differences right away. First, compare the armament. The M5 has a 37mm gun and 3 caliber 30 machine guns. The M-24 has a 75mm gun for the first time on a light tank. Right beside it in the turret is a caliber 30 machine gun. And another one is mounted in the bow of the tank. There's also a caliber 50 machine gun. This furnishes protection against low-flying aircraft. Next, compare the suspension systems. Here on the M5, we have volute spring suspension. On the M-24, this has been replaced by the new torsion bar suspension, which is smoother riding and more efficient. We won't go into the principles of operation and the advantages of the torsion bar system. They're clearly shown in another film bulletin, number 117. The third big difference between the two tanks is in the tracks. Tracks on the M-24 are all steel and 16 inches wide, about 4.5 inches wider than the tracks on the M5. A center guide in the track runs between the dual rubber-tired track wheels and helps to keep the track aligned properly. The drive sprockets fit into recesses in the track shoes. This feature, together with the center guides, greatly reduces the chance of throwing a track. 3 rollers support the track on the upper side. These support rollers are dual and rubber-tired like the track wheels, but much smaller. A compensating wheel for each track is mounted in the rear. It's connected by a linkage to the rear track wheel and helps to keep the track tension right at all times. To see how it works, we'll drive the tank up on an obstacle. This wrench will serve as a reference point for the position of the compensating wheel. As the rear track wheel is lifted by the obstacle, the linkage moves the compensating wheel to the rear, taking up the slack. Thus, any movement of the track wheel is offset by the compensating wheel. Notice how the center guides in the track fit into this slot in the compensating wheel. So much for the suspension system. Now we'll take a look at the rear end. By swinging the turret out of the way, we can get at either of the 2 radiator filler caps. Armored lids protect both caps. This grill lets fresh air into the engine compartment. This second grill allows hot air to escape. Flanking the grill are the fuel compartment vents. And under these covers, you'll find the spots to fill the 55-gallon gas tanks. The M-24 is powered by 2 V-type 8-cylinder engines developing 110 horsepower each. Here they are, designed for quick and easy servicing. Carburetors, distributors, spark plugs, and other units which require constant attention are placed within easy reach. Engine and transmission oil fillers are clearly marked. This helps greatly to prevent mistakes. tubes lead to the carburetor air cleaners in the fighting compartment. All covers can be removed easily. With the air outlet grill off, engines can be pulled or installed in a couple of hours, a full day's job on the M5. The engines are the same as those on the M5, but they're placed level and parallel, and the radiators are down in front. The fans are directly behind the radiators. They're driven by shafts which run the length of the engines and are connected to the generators. To function properly, these assemblies must be well lubricated. On each side of the engine compartment are a fuel tank and two standard 6-volt batteries. All 4 batteries together supply the tank's 24-volt system. There's an electric fuel pump in each fuel tank. One of the pumps must always be working to keep the fuel flowing. The fuel line from the fuel tanks to the engines contains no filters which would need cleaning or checking. Both engines can be supplied from either fuel tank. In front of the engines, hidden under the radiators, are the hydromatic transmissions, which are the first step in the train of power. Now let's leave the engines and trace the train of power all the way to the drive sprockets. The simplest way of doing this is to mark out a rough diagram on the ground. First, we'll sketch 2 boxes to represent the 2 engines. These, you remember, are mounted side by side. Each engine is connected to a hydromatic transmission. These transmissions shift automatically. They have a neutral position and 4 forward speeds. Both transmissions are connected to the transfer unit, which is mounted in the floor of the hull just ahead of the 2 transmissions. Here, the power output of the 2 engines is combined. Also, the transfer unit provides both a low and a high-speed range forward and one in reverse. From the transfer unit, the main propeller shaft takes the power forward into the control differential. This, in turn, transmits the power to the drive sprockets. And that's the whole story of the powertrain. The crew of the M-24, like that of the M5, consists of 4 men: the driver, the assistant driver, the tank commander, and the gunner. To save time and energy, both the turret and the cupola doors are spring-loaded so they can be opened and closed easily despite their heavy weight. Officially, this is the vision cupola, but the tank crews call it the greenhouse. 6 glass vision blocks give the tank commander 360-degree vision with the tank buttoned up. The greenhouse is set at an angle, exposing only 1-inch space to small arms fire, and the laminated glass is so thick it takes a caliber 50 at less than 200 yards to penetrate it. In addition to the vision blocks, there's a recess for a periscope. The center plate of the cupola door with the periscope can be rotated through 360 degrees. The plate rides on ball bearings, which, incidentally, should never be lubricated. They must run dry, otherwise dirt and dust would stick to them and gum the works. The scale around the outside indicates azimuth readings. Now let's climb in. All seats are adjustable and can be raised or lowered as desired. The vision blocks permit direct observation of the outside when the tank's buttoned up. Right behind the tank commander, mounted in the rear bulge of the turret, is the radio and interphone system. Both are operated by the tank commander. The tank commander can traverse the turret by turning this handle, which automatically cuts out the gunner's traversing control. It enables the tank commander to spin the turret around and point the gun at any given target. The turret can be rotated 360 degrees in either direction. Its movement is powered by an electric motor and an oil gear. The gunner's seat is in front of the tank commander's. And here is the gunner's power traverse handle. This control makes it possible to rotate the turret manually in case of failure of the electrical and hydraulic system. The 75mm gun M-24 is the latest in modern armament. The gun's ammunition and ballistics are exactly the same as those of the 75mm gun in medium tanks. Use of this large gun in a light tank has been made possible mainly because of the new concentric recoil mechanism, which is light and takes up very little space. Here's the elevating hand wheel. The gun can be elevated 15 degrees and depressed 11 degrees. The gun's firing button is right on the hand wheel, so there's no lost motion. Within easy reach of the gunner are the electrical controls of the turret, the stabilizer, and the gun. The gunner's telescope and periscope are connected to the gun in such a way that they are elevated and depressed with it. Of course, they traverse with the turret. When the gun goes into action, the assistant driver moves back and acts as loader. The 48 rounds of 75mm ammunition which are carried in the tank are stored beneath the subfloor and are protected from fire by liquid-filled containers. A hit on the ammunition will also puncture the containers and flood the compartments, cutting down the chances of fire. This looks like good space to set down your odds and ends, but you'd better not. Underneath it is the escape door, the only way to get out of this all-welded steel hull in case of trouble. It must be kept clear. When the bulkhead doors between the fighting compartment and the engines are opened, the engine fans act as ventilators. To draw out smoke-filled air while the gun is firing, the engines must be run at 1500 RPM or better, with both doors open. In cold weather, the fighting compartment can be heated by opening the bulkhead extension doors, admitting heat from the transfer unit. The carburetor air cleaners are mounted on either side of the bulkhead. Now we'll move up forward and watch the driver and assistant driver take the M-24 for a ride. There are hatches directly over each driver's seat. These doors swing up and out, and when they are open, they must be locked tightly. So eliminate all chance of the heavy doors swinging shut while your head's in the way by always making certain the latches are secure. The first step in getting underway is to switch on the master battery switch, located in the rear of the fighting compartment. Next, the driver turns on the ignition switches, one for each engine, and the warning signal should light up. But wait a minute. First, the emergency ignition switch must be turned on, because it's wired in series with the ignition switches. The light should always be on before the engines are started. But never drive with a warning light on. Instead of oil pressure gauges, red signals light when engine oil pressures drop below 12 pounds. The same lights come on when engine water temperatures rise above 240 degrees. There's also a water temperature gauge for each engine. Other warning lights come on when transmission oil pressures drop too low. These levers control the electrical fuel pumps. To lengthen the life of the pumps, only one should be operated at a time. You'll hear the engine splutter when it's time to switch over. With the transmission and transfer unit shift levers in neutral, we're ready to start the engines. Push both starter buttons at once. Make sure the warning signals go out. After selecting the gear range, all the driver has to do is step on the gas. The transmission will shift automatically. If more power is needed, the transfer unit is put into low range with the tank traveling under 10 miles per hour. To do this, the driver puts his left foot on the neutral pedal. This is a quick way of placing the transmissions into neutral. Now the transfer unit can be shifted. Then, when the neutral pedal is released, the driver again steps on the gas and the tank travels on in low range. Backing up always has to be done from a halt. All 4 transmission speeds are available in reverse, since the reverse gear is in the transfer unit. If there's trouble shifting the transfer lever into reverse, put it into a forward range and then shift into reverse quickly. Place the transmissions in low range for proper control while backing up. This prevents them from shifting higher than second speed. If one of its engines fails, the M-24 can still operate. When it's plain that damage can't be fixed on the spot, the drag of the non-working engine must be eliminated. So the disabled engine is disconnected by moving the input clutch lever in the indicated direction. A similar lever on the other side serves the other engine. Whenever you're driving with just one engine, be sure the transfer unit and the transmissions are in low. The tank can also be driven in reverse with only one engine. When the M-24 was going through its proof tests, a lot of trouble came from tracks being adjusted too tight. Drivers used to volute spring suspension thought a tight adjustment would prevent throwing tracks as it had on the M5, but they were wrong. The M-24 operates best with relatively loose tracks, having a sag from 2 to 3.5 inches. You can measure your track tension against a straight edge, such as a piece of string with weights attached. With the brakes released, the slack is taken up with a crowbar. While bearing down on the track with approximately 200 pounds pressure, we take our reading. 1 inch sag. Track's too tight. Track tension is adjusted by moving the compensating wheel. The wheel is moved back to tighten the tracks and forward to loosen them. First, though, it's necessary to loosen the clamp bolt. Now the lock plate can be shifted out of the way to permit turning of the track adjusting nut. Since the track is to be loosened, the nut is turned in the direction which moves the compensating wheel forward. The sag is always measured between the 2 rear support rollers. 2 1/4 inch sag. Now the track is as loose as it should be. Here are some other items which might give trouble unless they're carefully and frequently checked. Shock absorbers, track wheels, and suspension arm stops. Careful preventive maintenance is absolutely essential on any kind of equipment to get the most out of it. The M-24, with its low center of gravity, its wide tracks, and its turret directly in the center, provides a solid firing platform for its heavy armament. It's a light tank, all right, but it packs a mighty wallop.